Good afternoon. A very warm welcome to the one and all present here on behalf of Department of Electronics in association with IIC, IEDC and IQAC, St. Thomas College, Thrissur, autonomous to the National Seminar on Biomedical Hardware Implementation. The secret of getting ahead is getting started. So let's start off today's gathering with the blessings of Lord Almighty. For that, I invite Ms. Janaki PR of third year BSc Electronics for the prayer song.
കാണായ ലോകങ്ങൾ കാക്കുന്ന ദേവ കാരുണ്യ സിന്ധു നമിക്കുന്നു ഞങ്ങൾ കരളിൻ്റെ പൂക്കൾ നിൻ പാദതാരിൽ കാണിക്ക വച്ചു നമിക്കുന്നു ഞങ്ങൾ കാണിക്ക വച്ചു നമിക്കുന്നു ഞങ്ങൾ ലോകാ സമസ്ത സുഖിനോ ഭവന്തു ഈ മന്ത്രമീ ലോകമെങ്ങും മുഴങ്ങാൻ വിജ്ഞാനദീപം നിറകതിർത്തൂകാൻ കാണിക്ക വച്ചു നമിക്കുന്നു ഞങ്ങൾ കാണിക്ക വച്ചു നമിക്കുന്നു ഞങ്ങൾ.
Thank you, Janaki. Now, I would like to invite our head of the department, Mr. Jinesh Polsi, to deliver the welcome address.
Good afternoon, respected Executive Manager, Reverend Father Biju John Panangadan, our Principal, Dr. Father Martin K.A., our Vice Principal, Dr. John E.D., Dr. Ando Johnny T., Dr. Sister Alfonso Matthew, IQAC Coordinator, Dr. Father Anil George K., Dr. John Snadwath, President IIC, Nodal Officer of IEDC, distinguished guest and resource person Dr. Godwinraj D., Associate Professor of Amal Jyothi Engineering College, convener of the program Mrs. Anjali Marcos, head of the department, staff and dear students. With rapid advancement in technology and the demand for precise and accurate biomedical equipments and devices, the area of biomedical hardware find more attention on the present situation of medical emergencies. Department of St. Thomas College, Electronics, St. Thomas College, Thrissur, organizing a national seminar on biomedical hardware implementation. Our Executive Manager, Reverend Father Biju John Panangadan, is not only a spiritual leader, also he has the ability to motivate and manage the goodwill of our institution. I welcome our Executive Manager, Reverend Father Biju Panangadan, to this seminar. Our principal, Dr. Father Martin K.A., always taking a greatest care in academic activities and programs to boost up the skills and extracurricular talents of our students. I welcome our principal, Dr. Martin K.A., to this seminar. Vice Principal of Jubilee Block, Dr. John E.D., always gave constant support and mentoring to us in all our daily activities. I welcome Dr. John E.D. to this program. IQSC Coordinator, Dr. Father Anil George K. has an insight to develop the institution growth through the total quality management and gave timely support to us and coordinate this seminar. I welcome Dr. Father Anil George to this webinar. I also welcome Dr. John Snadwath, President IIC and Nodal Officer of IEDC to this seminar. Our resource person, Dr. Godwinraj D., did his research in nanomaterials and developed different biomedical and related products. Having long time experience in teaching and research, I heartily welcome him to this seminar. I welcome all the HODs, staff coordinator Mrs. Anjali Marcos, and all the staff members to this seminar. Students and staff from different colleges are gathered here for this seminar. I heartily welcome all the participants to this seminar. Once again, I welcome all of you to this seminar. Thank you.
Thank you, sir. Thank you, sir. Next, I would like to welcome Dr. Father Martin K. Principal of St. Thomas College, Autonomous Thrissur, for the presidential address.
Good afternoon to one and all. Reverend Father Biju John Panangadan, the Executive Manager of the college. Dr. Godwinraj D, Associate Professor, ECE Department, Amal Jyothi Engineering College, Kanjirappilly, the resource person of the day. Dr. A.D. John, the Vice Principal. Dr. Jinesh Paul, the HOD. Dear staff members, faculty members, delegates, and my dear friends. Biomedical hardware is the topic today. It involves in diagnosis and treatment and prevention of disease in humans. As the medical field is emerging, the area of biomedical engineering as well as hardware is an expanding field. We use the term bio to denote something related to life. When basics of physics and chemistry get applied to the living things, and we name them as biophysics and biochemistry. So when the discipline of biomedical engineering and hardware comes to medicine, when it interacts, it is called a biomedical field. As we know, it involves measurement of biological signals like ECG, EMG, or any electrical signals generated in the human body. Biomedical instrumentation helps physicians to diagnose the problem and provide treatment, to measure biological signals, and to design a medical instrument. Concepts of electronics and measurement techniques are needed. And hence, we, the Department of Electronics, I'm happy that we are organizing this webinar. Dr. Godwinraj, an expert, will enhance our knowledge in this field. Wishing you all the best for this webinar. Let me conclude. Thank you so much.
Thank you, Father, for your valuable words. Next, I invite Reverend Father Biju John Panangadan, the Executive Manager of St. Thomas College, Autonomous Thrissur, to inaugurate this session.
ഈ മീറ്റിംഗിൽ അധ്യക്ഷസ്ഥാനം അലങ്കരിക്കുന്ന കോളേജ് പ്രിൻസിപ്പാൾ ഡോക്ടർ മാർട്ടിൻ കെ എ, ആശംസകൾ അറിയിക്കുന്ന വൈസ് പ്രിൻസിപ്പാൾ ഡോക്ടർ ഇ.ഡി. ജോൺ, ഇന്നത്തെ റിസോഴ്സ് പേഴ്സൺ ഡോക്ടർ ഗോഡ്വിൻരാജ് ഡി, ഡിപ്പാർട്ട്മെൻറ്റ് ഹെഡ് ജിനേഷ് പോൾ സാർ, അഞ്ജലി മിസ്, സ്നേഹമുള്ള സ്റ്റാഫ് അംഗങ്ങളെ, പ്രിയ സുഹൃത്തുക്കളെ, ആദ്യമേ തന്നെ ഇലക്ട്രോണിക്സ് ഡിപ്പാർട്ട്മെൻറ്റിൻ്റെ നേതൃത്വത്തിൽ ഇന്ന് ഇങ്ങനെയൊരു സെമിനാർ സംഘടിപ്പിക്കുമ്പോൾ എല്ലാവരെയും അഭിനന്ദിക്കാൻ ആരംഭത്തിലെ ഞാൻ ആഗ്രഹിക്കുകയാണ്. വളരെ ആനുകാലിക പ്രസക്തിയുള്ള ഒരു വിഷയമാണ് ഇന്ന് നമ്മൾ ഇതിനായി തിരഞ്ഞെടുത്തിരിക്കുന്നത്. നമ്മളെപ്പോഴും കേൾക്കുന്ന ഒരു വാക്കാണ് എക്കോ ഫ്രണ്ട്ലി ആയിട്ട് ജീവിക്കുക എന്നുള്ളത്. എന്നാൽ ഇന്നത്തെ കാലഘട്ടത്തിൻ്റെ ഏറ്റവും പ്രധാനപ്പെട്ട ഒരു പ്രത്യേകത എന്ന് പറയുന്നത് ഇലക്ട്രോണിക്സ് യുഗം എന്നാണ് ഇന്നത്തെ കാലഘട്ടത്തെ അല്ലെങ്കിൽ ദിവസങ്ങളെ വിശേഷിപ്പിക്കുന്നത്. ഈ കഴിഞ്ഞ ദിവസം ഫേസ്ബുക്കിൽ ഞാൻ കണ്ട ഒരു ന്യൂസ് ഇങ്ങനെയാണ്. 70ഓളം വയസ്സുള്ള ഒരു മനുഷ്യൻ ഇലക്ട്രോണിക്സ് മെഷീനറി ഉപയോഗിച്ച് അദ്ദേഹത്തിൻ്റെതായ രീതിയിൽ ഒരു ഹെലികോപ്റ്റർ അദ്ദേഹം തയ്യാറാക്കിയിരിക്കുകയാണ്. അതിനെ പറപ്പിക്കാനായിട്ട് ആ മനുഷ്യൻ ചെയ്യുന്ന ചില കാര്യങ്ങൾ പ്രത്യേകമായിട്ട് അതിൽ എക്സ്പ്ലെയിൻ ചെയ്യുന്നത് കണ്ടു. ഒരു സാധാരണക്കാരനായ ഒരു മനുഷ്യന് അവൻ്റെ ചിന്തയിൽ നിന്ന് എന്തുമാത്രം സാധ്യതകളാണ് അവൻ്റെ മുന്നിലുള്ളത് എന്ന് ഫേസ്ബുക്കിൽ അത് കണ്ടപ്പോൾ എനിക്ക് തോന്നുകയുണ്ടായി. ഇന്ന് ഇലക്ട്രോണിക്സിനെ കുറിച്ച്, പ്രത്യേകിച്ച് ഈ ബയോമെഡിക്കൽ ഇൻസ്ട്രുമെന്റ്സിനെ കുറിച്ചൊക്കെ ചിന്തിക്കുമ്പോൾ ഇന്ന് ഒരുപാട് പ്രസക്തമായിട്ടുള്ള മെഷീനുകൾ ഇനിയും ഡെവലപ്പ് ചെയ്യേണ്ടതുണ്ട് എന്നുള്ളത് വളരെ പ്രധാനപ്പെട്ട ഒരു കാര്യമാണ്. പ്രത്യേകിച്ച് ഈ കോവിഡിന്റെ പശ്ചാത്തലത്തിലൊക്കെ നമ്മൾ കോവിഡ് പോസിറ്റീവ് ആണോ നെഗറ്റീവ് ആണോ എന്നൊക്കെ അറിയാൻ 1500, 3000, 4500 ഒക്കെ കൊടുത്ത് വിവിധ ലാബുകളിലേക്ക് നമ്മൾ ടെസ്റ്റ് ചെയ്യാനൊക്കെ പോയിരുന്നത് ഇപ്പൊ നമുക്ക് തന്നെ വളരെ പേഴ്സണൽ ആയിട്ട് വീടുകളിൽ ഇരുന്ന് ടെസ്റ്റ് ചെയ്യാവുന്ന, നെഗറ്റീവ് ആണോ പോസിറ്റീവ് ആണോ എന്നൊക്കെ അറിയാവുന്ന ചെറിയ മെഡിക്കൽ കിറ്റിലൂടെ അല്ലെങ്കിൽ മെഷീനറി സാധ്യതകളിലൂടെ നമുക്കതിന് സാധിക്കുകയാണ്. അപ്പൊ ഇനിയും നമ്മുടെ ആരോഗ്യ മേഖലയിൽ ഇതുപോലെയുള്ള ഒരുപാട് സാധ്യതകൾ ഉണ്ട് എന്നുള്ളത് നിസ്സംശയം നമുക്ക് പറയാവുന്ന കാര്യമാണ്. ഇന്നത്തെ ഈ സെമിനാറിൽ നമ്മൾ കേൾക്കാൻ പോകുന്നത് അല്ലെങ്കിൽ മനസ്സിലാക്കാൻ പോകുന്നത് ഇങ്ങനെയുള്ള സാധ്യതകൾ ഓരോ വിദ്യാർത്ഥികളിലും അല്ലെങ്കിൽ നമ്മുടെ ഡിപ്പാർട്ട്മെന്റിന്റെ തലത്തിലൊക്കെ എന്തുമാത്രം വളർത്തിക്കൊണ്ടുവരാൻ നമുക്ക് സാധിക്കും, അല്ലെങ്കിൽ അതിൻ്റെ പ്രാധാന്യം, ആവശ്യകത നമ്മളെ ബോധ്യപ്പെടുത്തി തരിക എന്നുള്ളതാണ് ഇതിൻ്റെ പ്രധാന ലക്ഷ്യമെന്ന് ഞാൻ വിചാരിക്കുകയാണ്. ഇപ്പോൾ വളരെ ആനുകാലിക പ്രസക്തമായിട്ടൊരു വിഷയം തിരഞ്ഞെടുത്ത് ഇന്ന് ഇതിനെക്കുറിച്ച് സെമിനാർ നമ്മൾ സംഘടിപ്പിക്കുമ്പോൾ ഈ ആധുനിക കാലഘട്ടത്തിൽ ഇതിൻ്റെ സാധ്യതകളെ കുറിച്ച് മനസ്സിലാക്കാൻ നമുക്ക് ഇത് സഹായകമാകട്ടെ എന്നൊക്കെ ആശംസിച്ചുകൊണ്ടും ഇതിന് നേതൃത്വം നൽകുന്ന എല്ലാവരെയും, പങ്കെടുക്കുന്ന നിങ്ങളെയും അഭിനന്ദിച്ചുകൊണ്ട് ഔദ്യോഗികമായി ഈ സെമിനാർ ഉദ്ഘാടനം ചെയ്തതായി അറിയിച്ച് എൻ്റെ വാക്കുകൾ അവസാനിപ്പിക്കുന്നു. എല്ലാവർക്കും നന്ദി. താങ്ക് യു.
Thank you, Father, for your precious words and blessings. Next, I call upon Dr. E.D. John, Vice Principal of Jubilee Block, St. Thomas College Autonomous, for felicitation.
Respected Executive Manager, Reverend Father Biju Panangadan, dear Principal Dr. Martin, the head of the Department of Electronics, please welcome an attempt to recollect on biomedics, especially in the present scenario. Let me congratulate the head of the department, Mr. Jinesh Paul, and all the members of the Department of Electronics for taking an initiative along the lines to recollect on the impact and importance of biomedics. It gives me great pleasure to wish everyone, especially Dr. Godwinraj D. from Amal Jyothi Engineering College, Kanjirappilly, all the best. And I hope the participants will have a great intellectual enlightenment by attending to this session. Wishing all the best to one and all. I remain. Thank you.
Thank you, sir, for your kind words. To deliver the vote of thanks, I would like to invite our staff coordinator, Mrs. Anjali Marcos.
I deem a great honor and privilege to propose the vote of thanks on this occasion. Firstly, I would like to thank our Lord for countless blessings and making the day a magnificent one. I would like to express my gratitude to all esteemed delegates for their presence and contribution to make the event a great success. I extend my gratitude to our Executive Manager, Reverend Father Biju John Panangaran, to take out time from his busy schedule to grace the event. And I also express my heartfelt thanks to our principal, Dr. Martin K.A., for his words of encouragement and support for this function. I thank Dr. E.D. John, Vice Principal, for his guidance and support. A special gratitude to the resource person, Dr. Godwinraj D, Associate for accepting our invitation. My heartfelt thanks to the HOD, Mr. Jinesh, for support and cooperation. Thank you all.
Thank you so much, ma'am. Now, moving on to the technical session. I feel privileged to welcome our resource person, Dr. Godwinraj D, Associate Professor of Amal Jyothi Engineering College, Kanjirappilly. He completed his PhD in Advanced Heterostructure Devices for Power Applications. He was a highly self-motivated PhD candidate with a 22 SCI international journals. He is now pursuing projects in collaborations with various organizations, including TSRI Taiwan. Just a little housekeeping before we get started. If you have any questions during the presentation, please comment them. I will bring them up at the end of the presentation. Now, without further ado, we will turn the time over to Dr. Godwin Raj to handle the technical session.
Thank you, Reverend Father, and thank you, principals. Thank you, Vice Principal. Thank you, Jyothi sir. Thank you, the organizing committee and this managing committees, and the faculties and the one and all staff members who is giving this wonderful opportunity to deliver a lecture on this biomedical hardware implementation and its design challenges. So, as I told you, as we discussed, as the said by expert teams earlier, so the biomedical is having an emerging field in electronics, especially because of the need of biohardwares is rapidly increased. So, as soon as you go on, we need to have so much sophisticated biohardwares to address so many problems and also to take role of our problems very easily to handle this difficult situations and to make us sophisticated to address the treatments. When you go for further treatments, we need to have sophisticated hardware. Means it will be easy for us to address our problems. So that is very easy for even a doctors, and that is very easy for a team of doctors when doing the surgeries. So that aspect, biohardwares are basically very important. So the problem is implementing of biohardwares is a big challenge. So as I told you, even the technologies increased a lot. When you look at the point of view of a student from a BTech or an MTech level, so when he took a project of biomedical hardware, if he wanted to do the project in his lab, seems like it is a big challenging work for them to do this task because of many issues, like there are many sophisticated technological instruments are using for fabrication, and there are many technical guidelines are there when you go for biohardwares. It will not come to market like what you think, just you make and will not come to market. It needs to pass all this technological ethical guidelines. And third is this hardware needs to be competitive with the market. So it needs to cross these three big challenges when a student is doing in his project as a biomedical hardware designer. So in the BTech or master's level, and that is another problem. Then again, very important problem we are facing is a lack of laboratory facility for fabrication these hardwares. So here I'm going to deliver basic of what is biomedical and how it is going to be useful for us, especially advanced biomedical hardwares. Is today it is rapidly increase the need, and it is reached to people a lot, and people are using it, and why they are using such hardwares and what is the use of it. And later we gradually move on to the technology, how the hardwares are making, and later we go on to the technologies of how we can able to make as a BTech or MTech project in our laboratory with very few set of lab instruments. So that especially we are focusing like inkjet film technology, that is for printing of this strip, and second one is a PCB, that is a making of circuits, and third one is optical technology for virology or COVID detection, or even like microscope hardware fabrications. And so as I starting the introduction, biomedical engineers are using that, medical engineers are using biomedical hardwares in a 3-4 different ways. Some people are making an instrumentation, and some people are making a diagnostic or therapeutic devices, and some people are making artificial organs, and some people are making other medical devices like the supporting materials for this artificial organs or therapeutic equipments. So what is our role is to examine what exactly we need, and for that we have to work. So what is the need of our essential in this particular category of work? So we have to identify whether the hardware we are making is a direct or it's an indirect hardware, or it is invasive or non-invasive hardware, or it is a contact type hardware, or it is a remote type hardware, or it is a sensor active type of hardware, and it is going to monitor real time or static type hardware. So that we have to identify for a competitive making. And advancement in machine learning and artificial intelligence made this type of hardwares even much sophisticated, and it is making good accuracy compared to the previous hardwares. So the role of biomedicals, electronics in biomedical is something characterized something like this one. A person is having such of sensors. He have one is pulse oximetry he have in her hand, and blood pressure he is in your wrist, and EEG sensor he is having in a chest, and inertial sensor something like EMG or EOG sensors he has in different parts. So these sensor data is going to a user interaction interfaces, something like we have lab Wi-Fi through Wi-Fi or Bluetooth, some hardware, some Wi-Fi networks. These data will be taken, and it is going for a processing, because as soon as people, electronic student might know this, the signal we get from this sensors is not a good signal, we can say. So it needs to be, it will be a noisy signal, and we need to go for a filtering process, and we need to go for sampling, and we need to go for analysis to take a particular type of signals. And we need to collect some type of signals, and we have to verify the signals whether it is in the range. Then you have to go for a physician. So it is having in a 3-4 layers of work. It is not like in one step it is doing. So such type of hardware every time it is very essential. So now this filtering, analysis, and accuracy part is much more easily made using advanced ICs and fabrication that we will discuss in further steps. Okay, so health transformation is something very important. One is why this global health transformation is required. So here I can say that this is one of the global health transformation report. We say that for a fitness, every human is spending around $0.3 per day. For example, consumer fitness, personal exercise equipments or stress management. So such equipments he is spending $0.3 per day. For chronic diseases, for example, diabetic, hypertension, and metabolic syndromes, so the metabolic syndrome, so he is spending around $3 per day average. Every people are such chronic disease people are spending. Again, for complex chronic disease, something like heart failure, COPD, cancer, and renal failure issues, in home, if he's treating, it's around $300 per day he's spending. And if he's treating in hospital, he's spending nearly for such complications $3,000 per day. So even apart from that, there are different issues like acute care, stroke surgery. That is a very complicated case will lead to happening. So this is a flow such happening in every healthcare transformation for a human study. So people are much more cautious compared to the earlier. So they want to control themselves. They want to control diabetic. They want to control hypertension. They want to control this metabolic syndrome. So people want to take necessary steps to avoid such failures of renal and heart failures. So they are much more sophisticated to use such instruments so that they can able to monitor their heart disease. They can able to monitor their BP. They can able to monitor their diabetic in real time. So that is the only solution for such problems. This electronic domain is got much more boom compared to the earlier. So the advancement, like some we are using smartwatch, advancement in this diabetic measurement in a real time without non-invasive process, these all make us to manage our disease, or even some extent we can able to control our issues of diabetic or hypertension very easily. So that this got much more attention compared to the earlier stages. So now another important thing, as I told you, managing these chronic diseases, there are diet-based things also come into that picture. Not compared to the earlier, people are much more aware about what they take and what they consume compared to the earlier. So earlier, the rice they consume is we having high glycemic index, which is a polished rice. Normally, though I can say there's a white rice. So people much more aware and do the research on this, and they want to see which type of diet is ideal for their health. So which type of rice is having, or which type of food is having less number of glycemic index. So as per to that, there are different type of foods they are coming into attention. One is they said there are different diets, like something like keto diet, something like mimicking diets, something like millet-based diet, and fasting diet. So there are different type of diets as used. So many scientific proven, scientific evidence we have on this millet-based diet. So I don't, diet is something like not a part of it. Just I glance in 1 or 2 slides why the need of such instrument and why people are using such instrument for this diet-based control. Okay, so here you can say that they are going for a study with 111 people, which is having for glycemic index study, and 56 people with pre-diabetic and post-diabetic studies, something like HbA1cs. So they can found that the people take GI glycemic index less food, something like a millet-based diet. Their average glycemic index they are taking is something like 52.7 plus or minus 10.3, which is about 36% lower than the typical what they take. And when they go for a polished rice, something like the food which is having a high glycemic index, and they are consuming something, it is around 71.7 plus or minus 14.4, and refined wheat it is getting 74.2 plus or minus 14.9. So this processed all grains and processed rice and refined wheat make the glycemic index extensively very high. So this scientific article is clearly saying when the glycemic index is effective, we can say that it should be less than 55, and its intermediate means it should be 55 to 69, and if it is a higher means it is greater than 69. So it should be very cautious about what type of food they take. So here from the same article, so this is an what they report about the glycemic index of different millets. This is foxtail and finger millet and kodo, little millet, pearl millets, and these are that. You can say this is 42, 54, 42, 35, and you can same time you can able to see this mild rice. That is we can say that is a polished rice, which is that 71.7, which is having very high glycemic index, and there's a refined wheat. This we can say wheat which is refined one, which is having 74.2, which is very high. So as the significance, we don't need to see much more. We can see the last one. So we can say this above one is having very low, and this below one part is having intermediate, and these two control part is having very high. So these people much aware nowadays, and they much clear about what type of millets for they consume, even as their routine breakfast or lunch or dinner. So as another one article, they is saying how the millet consuming people of 150 people, they choose the diabetic patients, and 80 they've consumed in the millet diet, and 70 they consume non-millet diet like rice, which is polished one, and processed rice. And here what they compare with that their cholesterol level, that the triglycerides, and this HDL level, the LDL level, and this is the fasting blood sugar level, and this is post fasting blood sugar level. So you can see that the green color one is clearly exhibiting that compared to this other 70 people, so this 80 people is having less even its HDL or LDL. So this is a clear evidence of this. They're giving the justification of this millet-based food as giving much attention. Now we'll come to that electronics. So how the role of electronics is playing here. Now we take some different type of food, like we want to take some millet-based food, or we want to take some keto diet or something alternative to treat with instead of medical-based. I want to treat with that diet-based. They want to go for it. So they need to monitor their diabetic in every interval, something like 15 minutes. What is the diabetic? What is the glucose level? I'm taking such type of millets. What is the glucose level? But after 15 minutes, after 30 minutes, after 1 hour, or after 2 hours. So regular monitoring or regular interval monitoring of glucose is much more essential when for a better management of our diabetic. So the advancement here happening is now the sensor, we have the sweat-based glucose measurement. We just have a sensor. We just place here, and we could able to have a receiver here, and this sensor is capable of converting this sweat into this electrons, and that convertible electrons is transmitted, and it is connecting to this receiver, and this receiver data can be monitored even with the mobile phone app, or we can with the same receiving device. So this you can able to monitor without any invasive process. We can see this below one. So if you want to measure a glucose, now the technique we have, many people we use is we have to take invasive method. We have to take a drop of blood with this pinch, and it will put into this strip, and this picking. But the advancement here happening is very simple. So just you paste a sensor, and you monitor yourself, and you guide yourself what type of food is better for you, and which type of food is making you to control your diabetic. You monitor for 1 or 2 weeks, and you can able to suit that particular food for your life. Even such people are much more aware. That is where this electronic plays. What I'm talking is the commercial product, even it is available in online. This is called continuous glucose monitoring system. So this continuous monitoring system is given much more attention to the people, and this is a very simple electronics hardware. We'll discuss how we can able to make in later stages. So next one is BP measurement, and earlier we will be measuring BP with very huge machineries, and now we have the smartwatches. The smartwatch can able to now display your systolic and diastolics, and you can able to give the pulse, and it able to give the SpO2. And many researchers are working on to get the diabetic details on the smartwatches. This is also a non-invasive process, and even the accuracy of smartwatches is not much more accurate, but still the commercial FDA approved products, something like we have at the bottom. So these all digital meters also can able to outperform well in measuring this SpO2 as well as your pulse rate as well as your blood pressure levels. So these are some of the hardwares. You can able to monitor your blood pressure levels, and above are some of the hardwares you can able to monitor your glucose levels when you are controlling or when you're monitoring your chronic diseases daily. So what is the advancement is going to happen here is, so in later stages, they're going into implement into the MEMS devices. So MEMS is something like, not we think, this is all the packages of sensors, all the packages of IC circuits, all the packages of transmitters, everything can be integrated into one chip. So as you can see that this size of the chip is around 3 centimeters and into 2 centimeters. So this chip can able to measure, and this chip can able to process your information in the ASIC. As you know that ASIC can able to, in the ASIC itself, you can able to do the filtering and programming languages. firmware, so that you can able to easily control this diabetic monitor your systems. And later stages, this ASIC can be able to integrate it into this BioMEMS. So then there is a transmitter is integrated. Everything is done within a smart device. This device is sufficient to transmit your all data into your mobile devices, or it may be any monitoring systems. So this advancement in this global healthcare transformation is happening today in the research level. So what MEMS can able to measure? So as you know that if you measure one to the pulse oximetry, so we can able to easily need of any optical signals. So optical MEMS can able to do it. So as soon as similar, we can able to measure all the parameters from the MEMS, something like accelerometer, gyroscope, pressure, microphones, ultrasound, optical, thermocouple, gas sensors. So all this measurement can able to measure using this BioMEMS, which is going to be coming as an emerging field. So it is going to outperform well, and your PCB size is going to be reduced, even it's smaller, and your bandwidth is going to be, or your efficient of management in your diabetic is going to be increased even much further in the future healthcare system. And your detection hardware is going to be much more smaller, even in imaging hardwares, or it may be a IVD, or it may be patient monitoring system, or it may be a pharmaceutical research or drug delivery or patient care. Most of the hardware is going to be very small, and it's going to be very efficient also. So this is what advancement of BioMEMS is going to happening. So that is, we can say it is a research level. We are going to discuss about what is there in today's market and how we can able to make it. So this is how the MEMS is emerged from 2000, and how different MEMS hardwares they made, and they already implanted into different today's hardwares. They were used in blood pressure monitoring systems, or in different hardwares they already integrated this mechanical based system in the micro levels. So this is what a market of this MEMS is going to be in the futures. So next one is the flexible electronics. So flexible electronics means earlier we'll be working into a circuit, and we'll make a circuit which is be very big in size. And what is going to happening is that circuit is not a flexible one. So if it is not a flexible, what is the problem is it is not going to be a wearable one, or we can say that it is not going to be user friendly. So we have to keep this like a mobile phone, and we have to keep this device with us for every monitoring and every aspect. And if we have a flexible type of hardware, what is the advantage is we can wrap like a watch. So that is sufficient for us to work on. So many displays are already come in OLEDs and e-paper displays. So many are already there in the market with this technology. So now this flexible technology is also getting into this biomedical for their applications. So as I told you, this we need to work on whether this is possible to do a BTech or a bachelor's of BSc or MSc project in the bioinstrumentation, whether the sufficient lab facilities are there for this to fulfill to work on this particular domains. So that we have to discuss. So the second thing is, third one is ink print technology. So ink print technology is something like we have a extrusion based bioprinting. So we apply some bio ink on top of it and inside this syringe. And this is not a syringe, this is a piezo header. We can say that this is what having in this printer, print head. So these piezo activators will give a drop, give a pressure, and according to the pressure, activated pressure, the amount of ink will be dropped. So we can able to make a structure of polymer what we want, so that we can able to use for a tissue engineering or drug screening applications or a disease control applications. So this ink print technology is also used for a flexible PCB applications, as I told you. This method is functional for a DNA, an enzyme, and antibody-based links we can able to make, and there is no requirement of any additional hardware other than ink for the particular making. So this is how one strip we have. So this is the internal architecture of a strip, and this is a bottom scale PCB, and on top of that different coatings were come. So this is what we use, one of the AccuCheck bio strips. So this is how the strip implementation is happening, is in this glucose strip. This is called one is called a working electrode, another one is called a counter electrode, another one is called reference electrode. So we'll be pasting this, coating this enzyme with this working electrode, and we'll be putting our blood samples there, or maybe the saliva samples, whatever we have, which is connected. And according to that, it will get reacted. The electrons will be released, and it will be compared with this reference electrode. So from the reference, what is the deviation with the working electrode, and it will be tested with this. It will be counted by this counter electrode. So as soon as I told you, this working electrode released electrons will be very less. Something we can say it will be in the range of microvolt range in this case. So we need to go for a micro amps range. So we need to go for a huge amplification. So we need to go for, first initially we have to use a current to voltage converters, then we should go for an amplifier, then we have got to go for a different filters. So this is how a simple example of a glucose strip electrode hardware which will be making with respect to working with this glucose strip measurements. Okay, so this is with a different measurement. As I told you earlier they will use for glucose measurement is a blood, and now advancement they are using sweat, which doesn't need to go for an invasive process, and upcoming they are going for a saliva based and urine based and tears based and breathe from acetone, and another one is a breathe the indirect condensate. So these all parameters also sufficient to measure for a measuring your glucose range. Doesn't need, it needs to be only blood is required or only saliva is required. So, but the problem is what that amount of concentration we get for every measurement is very small as compared to the blood. We'll get 2 to 330 millimolars per liters we are getting, but compared to the others it is very small. So we need to go for designing of such sophisticated hardwares to make display that or calibrate such results with the ICs, and then we have to go for a display. So that challenges are there, and already sweat is, I told you, which is already there in the market. So as I told you earlier, so we'll be thinking of how we can easily make one flexible electrodes. So as in that commercial manufacturing process, flexible electrodes are making using ion implantations or lithographics, or even some extent they go for an ink print process only, but it's in the mass productions. But here we can make, as I told you, I'm making a graphene ink. So the graphene sample one I'm taking, and I put, this is called the piezo ink head. That is a printer one. So that printer in the printer cartridge, I'm filling this graphene ink. This is a maybe conductive ink. It's not a insulative one. So the properties change with some adding of polymers. So I'm giving a design. For example, this is, you see this what you are saying here. This pattern of design, script design, I already given. So in the design of printer in a computer. So as soon as I given this print option, so it is easily printed something like in a paper. So or it's easily printed on a flexible sheet. So we could be able to get a result in a flexible sheet with very small investment of a printer. That is how we can easily make a hardware. This is a flexible PCB. This can able to easily integrate it. You can able to make any number of PCBs and any number of designs also. So doesn't mean it needs to be a particular design. Doesn't mean it needs to be a small size. According to our requirements, we can able to make it. So it needs to be a conductive ink. The cartridge ink needs to be replaced with this conductive ink of graphene. So as I told you, a single chip also can able to measure different parameters. So the screen printed or ink printed casting we are already done. Solution of blood or solution of saliva we are already taken. And then we're going to measure, one side is a glucose and one side is a lactose and one side is a uric acid. So here we are putting our sample of blood, or that sample we are going to measure, and here it is measured here that it will pass through this glucose electrodes, and according to that the electrode output will be given to that hardware detectors, and here the lactose output will be given because the enzymes what I quoted here is to measure this lactate, and here is a uric acid detectors. So this is easily going to create and measure the urea. So within one drop of blood, these three parameters can be able to detect. Again, this is an imprint process. This is not made in a huge laboratory. So very simple process. You can able to make only with that enzymes reactions. You can easily make different type of hardware you want to do. So here is a procedure for RGO, which is a conductive substrate material we making for this ink process. So graphite powder and H2SO4, and we are adding with NaNO3. So here slowly added. So you go through this process, you can easily able to make this final product as a powder. Then we have to add the solution for that is for mixing it, making to the conductive, and that solution is going to be used, and it should be filtered with this micro filter, because cartridge needs to be very pore size is very small, so big particles can able to damage within the printer head, or we can say cartridge head. So that microfilter, after the microfilters, that solution needs to be taken for printing applications. So 0.22 micrometer microporous filters. This is not very expensive. Around 100 filters, you'll get for around 200 or 300 rupees. So such an easy process of fabrication of RGOs. Even not only RGOs, you can go for any type of conductive inks. Not only different type of conductive inks we already having. So any type of conductive ink is going to work out with this flexible printing. Very similarly, we also can be able to print the enzymes, because the substrate is only a medium. Substrate is something like it is taking the electrons and it is conducting with the hardware we are interconnecting. So also we need a reactant. So if we add a glucose, so that enzyme needs to be there to react with this particular saliva, or for example, you want to make urea measurement. So for that particular enzyme is required. For glucose measurement, such enzyme is required. So that enzyme also can able to print using a different cartridges, and the setting of the cartridge can be altered according to that the flow of output from each cartridges. So that make to perfect printing of a perfect ideal solution in the particular area with a particular output. Exact density also can be controlled. So this making of graphene not only going to used in one application, it is going to used in n number of applications. So you can also make in different patterns, like one is a motion based, that is a piezo based, which is what we discussed, and there's a drop casting based. You can make a stencil and you can put your graphene ink and smash it and remove the stencil, you will get the desired output. Very similar, like as I told you, the screen printing also it is possible. And electrode deposition is also one of the method for making this graphene. And syringe also is sufficient to make a design. And electrospraying is also possible to make such design on a substrate. So this based sensors can able to do in any type of, for example, graphene in nano pellets and graphene in GO format, or nanoribbons and enzymes, antibodies, nucleic acid. So for any based screen printing is possible with this graphene based printing technology. So there are some challenges are there in this low cost ink print technology, where we have a restriction type of material used for fabrication is given. So we need to have a material which should be highly purified graphene. So it have some internal resistance. As I told you, as you worked in electronics, you know much about this the copper tracks we have. So the impedance of copper tracks plays a very important role in tracks of every conductivity, every conducting in circuits. So as very similarly, that resistivity of a graphene is also plays a very important role. According to that, you have to do the calibration process. So that will not directly affect the performance, but the entire reliability of this sensor is going to be affected if you are not much aware of it. If you are clearly aware of it, things will be okay. And if you're not aware of it, it will be difficult. And another one is this sensors is not much explored, means people not used much this type of techniques for fabrication. So it is something like an entry level. Again, cartridge is something a very big one. You need to make very huge number of graphene ink for that. So as I told you, as I giving a suggestion, instead of making a one big cartridge, you take the quantity how much you need for that pillars, because that there is a wire is connected from the pipe is connected from a cartridge to that head. So you fill on that and you tap it, so that small amount is sufficient for your application, because you are not going to print for an industrial application. For your project, you need only one. So that one or two PCBs, flexible PCBs, that also possible with this particular one. And second one is many people are thinking to work on this EEG, ECG, and EMG hardwares. There is a bio acquisition hardwares, so where there is a real application where people are using. So these are some of the potential biopotential measurement ranges, and these are the frequency ranges, and these are which you much more aware of it. So I'm going a bit faster so that I can able to complete within a time. So these EEG, EMG, EOG measurement circuits, earlier it will be very huge and very big in size. So what really happened is It needs to be characterized by high impedance, and it should be low frequency and low amplitude and strong background noise. So these all studies needs to be done. So if you are making one EEG or EMG or ECG circuit, so now one of the IC, as I'll discuss with us, is called Ads129 Eeg Ic. This is basically ADC one. This is not at a microcontroller internal. So this is having an inbuilt amplifier EGAs. So what really happen is the filtering as well as the amplification process is done already in the IC itself. So the number of components using for reducing the filters and the amplification is completely avoided. And this is called 8-channel ADC. So we can go for eight different inputs in the same time. So they have different variant of 4 channels, 6 channels also. But unfortunately, this is having high demand of IC. So this is not available in stock for 8 channel. But others are also available for around 2,000 to 3,000 rupees, this IC. So this single IC is sufficient to make a very good number of research on ECG, EEG, and EMG with a single board. That is a very big advantage. So all these three can be done, and you need this amplifier of 16 kilohertz single channel sampling rate, and put it into this your Arduino microcontroller and make your circuit perfect for your applications. So there are many open source integration hardware is available. Softwares are available. You can easily integrate at your Arduino microcontroller with this PC, and you can able to make the output from EEG. You can monitor the systems. So this is what an internal structure of this IC. Earlier, people are working on this filtering process much more. Like as you see, this in the box. These are the internal things, and where they have the low pass filter, and there is a shield drive, which is very important, and there is a buffer, and there is also a programmable reference electrode path, and these all, and the power management thing, and external clock signals. So these all parts are covered within a one IC, so that this all problems will be reduced. Only you can concentrate on the channels as well as the electrodes, as well as you have to concentrate on this output part. So these are the output data acquisition from these particular ICs. As you see, if you have a good shield, means there is a covering of protection of this PCB, there is a less noise compared to that. And as you if you make no shield, you can start to feel the noise is getting into. This is called, because these are the low frequency signals, as you are aware of it, and the external disturbance of noise, that is 60 hertz noise, and there is a white noise, and the different type of noise will get entered into the circuit. So the good shielding of such circuit makes this circuit for a better application of your samplings. So this is how a hardware can make, and this is how can able to integrate on your hands, and within one shot you can able to make EEG signals, EOG, ECG, EMG signals from your head and hand and your thighs. So this simple setup can able to make your hardware ready for your project. And third one is what I'm going to discuss is, so whatever we discuss now are the PCB based technologies. So we need to buy a hardware, we need to place your circuit, and we need to make a PCB out of that. So now making PCB, it's a very big challenging compared to earlier, because PCB making technologies are, even we have to, if you make a design, you have to order from that online to somewhere else, to abroad, or way PCBs, or there are different websites we have for ordering PCB design. So they will make 4 PCBs minimum for a particular design, 4 or 5 PCBs they will make, and they will take nominal charge of around 600 or 700 rupees. In some extent, they'll charge multi-layer PCBs, they'll charge more than like 2,000 or 3,000 rupees they'll charge. So you will get the PCB, and now what is the next process? That's what we are going to concentrate, because making PCB in our lab is good. I'm okay with that, because we tried making PCBs. I'll show you one of that PCB we make. This is one of the PCB of Arduino, and this is a small scale of Arduino PCB. So also find the final PCB is something like this when you make it in real. But when you make a PCB in your laboratory, it doesn't mean it have a multi-layer. You cannot able to make multi-layer very easily. So it is ideal for a 1 layer, it is most efficient, and for 2 layer, it's okay. With the reverse, we can able to make 2 layer PCBs within 30 minutes. Yes, your circuit can be made within 30 minutes. That is ideal for prototyping. Yes, I want to test my circuit in a very short time. Yes, fine. But what type of circuits we are working is, it should have a ground plane, it should have an internal reference planes, and it should have a power planes. Means different layers of PCBs having different layers of operations. So that circuit needs to have at least 6 layers. So such PCBs making is, I say not possible, it is quite challenging one. It is not very easy. So better option is you design your PCB and give an order to companies. So they will make the PCB and you work on the next process. So these are PCB manufacturing process, how from the board cutting, how this lamination process is there in every stages. So after the PCB we got, the first thing you have to do is you have to apply the solder paste. So in industry, there is a unit called assembly unit that also we have here, assembly, so that we'll take the stencils and we'll keep the stencil and apply the solder paste using a stencil printer. And then we'll go into that pick and place machine. So the pick and place machine will place the components wherever you want. So then we'll go for a reflow oven. So if you give to the reflow oven take that, it will heat up. Reflow oven is having some settings because all the circuits is not same. So some circuit is having extensive temperature. For example, within short time it needs to be, temperature should be peak, and it should be also, it needs to reduce, otherwise your board will get damaged or the component placement will not be perfect. So such cyclic frequency or wave frequency of soldering is much efficient. So it is very efficiently done by your reflow oven. And then you go for an inspection. Yes, whatever that components are already placed there is perfect or not. And then you go for a testing. So this is a 5-step. This is called assembly. This stencil unit can be easily changed by a syringe. A syringe you take and you cut this entry and you take some solder paste, which is having very less tin, and you apply this solder paste on the pad. This is the pad he is applying here. So wherever the pad is required, you just apply. And here you take a tweezer and you place your components. Wherever you want, you place your components. There are two ways of making is, one is you can use a microwave oven and you take a Teflon tape and place it and you put it. You apply 3-4 seconds, it will get adhesive your components. Or you can do is you take a gas stove, you can take some sand, it should be polished sand, and take some foil and lock of Teflon, and you put your board on top of it and heat it. So once it is that the sand is much heating temperature is reached, then you put your board there. So your component will be placed within 5 to 6 seconds. Instead, you put on the earlier, it will be very cautious about this process instead compared to the other process. So easily you can able to mimic the assembly process with this small ideology of putting your solder paste and using as pick and place of tweezers, as well as the heating of your fine sand. So you can able to overcome with this all this stencil and pick and place and reflow one. But one more thing is this instrument, if you make, it will be perfect when you, especially when you go for a low pitch component, something like you go 201 waste resistors. It will be very extensively, very small. You cannot able to see it even properly. So for such application, it will be much more difficult. So for that, you have to choose a big size, something like at least 0.24 size components you need to take, any resistor or capacitors. As I told you, if you make this a low-cost PCB manufacturing technology, there are some challenges also there. This is not a challenge, we can say this is maybe because of inexperience how we made the mistake. There may be sometime there is a bulging of circuits, it happens. And there is sometime it will go for excessive soldering. So you going to find to apply for some soldering, but excessive soldering may be applied on the tracks. So what really happen is it will get interconnected with the adjacent tracks. And sometimes what happens is you will skip the solder. For example, you see this this capacitors. Here one track is they place the solder and the other track is missed. So what really happens is it is not a conductive one. So it lead to give some different effect on the board, as we know that. So this is an inaccurate placement, and these are some of that issues we have in this low-cost PCB assembly process. But still, you can able to manage with this training of by yourself. If you make 2, 3, 4 boards by yourself, easily you can able to make it. Unlike you go for a huge number of production, easily you can manage with this such assembly process. And third one is the optical based hardware. So optical based hardware is which is not so easily you can make. But still, there is a possible we can able to mix. This is one of that COVID-19 detection system process, which is I'm taking the graphene sample as you make, I'm putting this dopant and I'm applying this sample of saliva into that solution. And I'm giving this laser source from the Raman spectrometers. So as the Raman spectrometer hit on the surface and it will get refracted, so the scattered signals will be studied. As you know, the Raman signal is very weak and it needs to have it detected by the good detectors. So that needs to be taken and that signal needs to be plotted with this their intensities as well as their wavelength. So as per that diffraction of the signals, we can easily say that what is this particular Raman signal. It may be this is at which type of waves. So we can easily predict that already one team has made in 2021 with the graphene and the Raman spectroscopy, how we can easily measure this COVID presence or not within very short time. It is not even, they said, it is a very quick and faster efficient compared to 2 hours, 3 hours waiting time. So here what I'm going to discuss is how we can make this Raman spectroscopy in a very easy method so that it can be able to integrate with this optical. So here what I'm saying, I'm using a source, a laser source. Here I'm putting a sample, and here I'm going to use a filter and collimator lens and a spectrometer and the system. So for Raman filter, I'm using this OD6 filter, which is available online. Laser diode is 532 nanometer laser diode. So I'm taking, which is 50 milliwatt. And I'm using the Raman probe, KWS, that is a OPU unit. There is optical pickup in there, say, and there is optical fiber cables. So this much is sufficient. And if you have spectrometer also, you can able to make it, which is not shown here. So this setup is sufficient to work as a Raman equipment, Raman filtering stages. So with this setup, this is how we made as a Raman spectrometer. And here what our pesticide sample we studied with this one. This is not integrated with COVID detection. So we are working on to integrate this system with the COVID detection. This is already working efficient for pesticide detection in the field as well as with the samples. So this intensity peak very easily taken from this Raman signals. And what is advantage is very simple process. It is a very low cost and simple construction. You can able to make very big instrument which is using for R&D, this Raman spectrometers. And here the spectra of toluene, acetone and naphthalene were obtained using this one. And here are the spectra which is not normalized, which we got very good calibration with the experimental data which we studied using this one. And this is what naphthalene, which is a wavelength one. And this is what glyphosate, which is a pesticide one, which we detected using this wavelength. When you normalized, we'll get peaks on the particular resonant wavelength. So after this process, we are planning to work on this COVID detector as a Raman spectroscopy as a COVID detectors for a particular application. So entire system can be made with this graphene and some dopants as well as this Raman signals. So as this conclusion, I want to say that this particular system can able to make extremely for single usage, and this can able to work very efficient for our applications. So whatever you work, make sure that especially when you work for a strip based systems, it have some shelf life, because it should not get contaminated, or the parameters shouldn't change after 45 days or after 190 days or after what the expiry date we given. Even after that, it shouldn't change. So that is called a shelf life. We say that about electronic system, or even especially that strip based systems, that we need to be work very carefully. And when you work for the shelf life of it, so when you do first design, whether the parameters of this output is changing or not, you need to be very cautious about when you do for a strip based system. And when you go for a future detection system, and you can able to measure this biofluid based, it's like saliva based, and even you can sweat based. Sweat based is already there, so even work on this so that you can easily monitor your blood samples very easily for other parameters. Not only that glucose, you can go for creatinine and urea and lactase. So these parameters also can be able to work on this with their supportive enzymes. And another one is that you just work on most concentrate on this non-invasive process than invasive process. Invasive process already we have, but invasive process which is very accurate compared to that non-invasive process. We can say that. So the blood, what we drop on it, it is suddenly reacting and it is getting work. So in non-invasive process, we have some challenges. So like if I keep this on my stomach, so if I move it, or if you do some activity, there might be some possible of loose in that sensor, and there may be some disconnection with our body. So after that, the result we are getting may not be calibrated, or it may be wrong. We cannot say perfectly. Most often it will work fine, but that is also a issue we are working. The people are working on it. So when you go for non-invasive process, these all things needs to be considered. Any type of measurements or any type of system you are going to make with this non-invasive process, such directional control and such system needs to be concentrate much for your future applications. That needs to be done. And another one is the control algorithm. So now there is a controlled insulin system we have. So that is another one things is connected. So as soon as according to your blood glucose level, that insulin will be taken into your body as per your requirement. So it will be something like a calibrated one. So how much you need, it will be delivered. So that is also possible. There is also there in the application I'm saying. So for that, you also have to work for different monitoring system, something like LDL and HDL measurements. For different parameters also we can able to work, not only for glucose measurement techniques. So any questions you can ask. If you have any doubts, you can ask.
Thank you so much, sir, for your valuable insights on this topic. It was really informative. Hope we could hear a lot of lectures from you in future. Now we have come to the end of our session. I'm taking a moment to thank each and everyone gathered here. My sincere thanks to our principal, Dr. Father K. A. Martin, our executive manager, Reverend Father Viju John Panegade, our vice principal, Dr. E.D. John, our convener, Mr. Jinesh Polsi, our staff coordinator, Mrs. Anjali Marcos, and all teaching and non-teaching staffs of St. Thomas College Autonomous. My special thanks to our source person, Dr. Godwinraj D, who presented this seminar, and also to all of you who have attended this seminar. Let's conclude this session. This is Jelen Johnson, first year MSc Electronics, signing off. Thank you.